So today's topic is rational numbers. Introduction to rational numbers. What are these rational numbers actually? We have learned what are natural numbers, what are whole numbers, what are integers. Okay. Now we need to know what are rational numbers. Okay. Rational numbers are nothing but the numbers which are in P by Q form, where P and Q are integers. Okay, belongs to integers. Okay, you know what are integers? -3, -2, -1, 0, 1, 2, so on. So you can take P and Q values from these integers. You can take any number, any value. Okay, example, I am taking -3 by 4. So this is P value and it is Q value. So don't you feel it is in the form of P by Q? So any number if you take which is in the form of P by Q, where P and Q belongs to integers, are called rational numbers. And you should not take Q as 0. What will happen if you take Q as 0? So we cannot. Let's take an example, 4 by 0. Okay, what is 4 by 0? Let's take first 4 by 1. Okay, 4 by 2, 4 by 3, 4 by 1, then 4 by 0. Let's discuss this first. Okay, 4 by 2. So I am dividing 4 with a 2. Okay, 2 2s are 4. What is the remainder? What is the remainder? 0. And what is the quotient? 2. So okay. Next, 4 by 3. I am dividing 4 with a 3. 3 1s are 3. I got a remainder of 1.0. 3 3s are 9. Again 1. So it goes on, continues in the same way. So 3 3 3, so on. So the value of 4 by 3 is 1.33, so on. See, what is 333, so on? This comes under another topic that we will discuss after 2-3 days. Okay, definitely I want to discuss what are these numbers. Okay, leave over this. Okay, no, anyhow I am getting a quotient number or not? See here, 1.33 I am getting. Okay, leave it. Next, 4 by 1. I am dividing 4 with a 1 table. 1 4s are 4, remainder 0, and the answer is 4. So I have done. Now let's go for 4 by 0. I am dividing 4. 0 1s are 0, 0 2s are. See, when I'm dividing with a 3, 3 1s are 3, 3 2s are 6. Because I have 4 here, I cannot take 6. So I went back, I have taken 3 1s are 3. Now let's divide in the same way with our 0 table. 0 1s are, 0 into 1, 0, 0 into 2, 0, 0 into 3, 0, so on. You take any number, multiply with a 0. Okay, any number, your name, it can be any number, so the value will be 0. Are you able to find the division here, quotient here? No. So it is not possible to find the value when the 0 is in the denominator. It is called as infinity. Okay, it doesn't have any value. Okay, 0 cannot be, we cannot divide any number with a 0. It's nothing but undefined value. You cannot find the value. So either it can write down infinity or else undefined. Because it is undefined, we cannot take Q as 0 in P by Q form. So what is the definition of rational numbers? The numbers which are in the form of P by Q are called rational numbers, where P and Q can be any integer. Okay, but Q should not be equals to 0. If you take Q is equals to 0, we cannot find the value. In the definition itself, it is there that in the P by Q form, Q should not take 0, because if you take 0, we cannot find the value. We don't know what is that value. So other than 0, you can take any integer. Okay, so that value will become rational number. Okay, so now 4 by 2 is a rational number, 4 by 3 is a rational number, 4 by 1 is a rational number, except this. Okay, clear? So I have taken every time here 4. You can take any value. Example, -3 by 2, this is a rational number. -1000 by 5. This is also a rational number. Teacher, 5 we can divide. Yes, we can divide. 5 ones are 5, 5 twos are 10, 0, 0. So what is the value? Minus 200 by 1. So whenever you are dividing, when you are getting denominator as 1, the value will be the numerator value itself, 200 minus 200. Okay, why? Because when you divide any number with a when you divide any number with a 1, you'll get the same number. 1 200s are 200, 200, 0 remainder 0. So what is the quotient? 200. So whenever I'm dividing a number which is in the form of p by q, I'm getting a quotient, right? So rational numbers are denoted by letter q. Clear? So rational numbers are also called as quotient numbers. Quotient, how you are going to get? Take any value, take any number, 7 by 5. So it is p and it is q. It is in the form of p by q. Therefore 7 by 5 is a rational number, or else it is a quotient number. It is denoted by q. Why we are denoting with a q? Because it is a rational number. It is a quotient number. So let's find out the value of this one. Actually 7 by 5 is a rational number. If you want to convert them as a quotient number, you can divide simply. You are dividing 7 with whom? 5. Okay, 5 ones are 5, 2. Okay, so what is the quotient? Here quotient is 1, remainder is 2, divisor is 5, dividend is 7. Clear? Are you able to follow me or not? So rational numbers are nothing but the numbers which are in the form of p by q, where q is not equals to 0, are called rational numbers. It is denoted by the letter q. Why? Because when you try to find out the value of a 4 by 2 or any number which is in the form of p by q, you are going to get the value as quotient, that is denoted by q. That is why these rational numbers are called quotient numbers. Clear? So let's discuss where these rational numbers exist. So this is called as a number line, as we know. How to draw a number line, which we have discussed already. So one more time, if you want, you can listen. Now draw a line. Okay. If you want to divide this line into some parts, just draw a point on wherever you have numbers on a scale, okay, a ruler. Just put a point, just mark a point on a number line. Okay, this is the number line. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on. So this is called as a number line. Okay, so for example, if I'm taking 1 and 7, between 1 and 7, how many natural numbers exist? Just listen to me carefully. How many natural numbers I said? So it is a number line. It is a number line started with 0. So it is a whole number, right? It is a number line of a whole number. Okay. So if you remove this, it will become a natural numbers number line. Okay. Now 1, 2, between 1 and 7, how many are there? 1, 2, 3, 4, 5. 5 natural numbers exist between 1 and 7. When you are talking about natural numbers and whole numbers. Okay. Now let's discuss where these rational numbers exist, and let me explain you. 0 to 1 is 1 unit, 1 to 2 is another unit, 2 to 3 is another unit, 3 to 4 is another unit, 4 to 5 is another unit. So if you observe the length, when I'm drawing, the length of each and every unit is 1 centimeter. Okay, this is the main rule that you should keep in your mind while drawing this number line. Okay, so each and every unit is going to have same length. This is the correct way to draw a number line. In our class, I used to draw just roughly. Okay. Now let us discuss 0 and 1. Now 0 and this is 1. Imagine I have taken only this part. Okay, 0 and 1. So when I have drawn this with a ruler on the first diagram, I have taken only 1 centimeter. So imagine by making it as zoom. So when you make it zoom, it looks like this. Okay. So always positive numbers are at the right side of a what we call a 0. Actually, before explaining this, I need to explain one more point. Okay, please excuse me. Okay, let me explain one more point. Okay. Okay, this is number line. See, just observe how I'm drawing after. I just want to explain you where these rational numbers exist. Okay, now 0, 1, 2, 3, 4, 5, so on. -1, -2, -3, -4, -5. Okay, it is a number line. Okay, now these are called integers where you can see these numbers, but there are some numbers exist between 0 and 1, 0 and -1, -1 and -2. There are small which cannot see over here right now, but there are some numbers which are existing in between 0 and 1. Between each and every integer there are some numbers which are existing. Those are called rational numbers. And let me explain you, each and every unit is divided into some parts. If you take some few examples of rational numbers, let us take two rational numbers. Okay, -3/2 numbers are nothing but which are in the form of p by q, and p can be any integer I said. So you can take even negative number also. If you take negative number, it will become -3 is a negative number, 2 is a positive number. Together -3/2 is a rational number which exists in negative part. Okay, so it exists in left side of a 0. So whenever you want to draw any, you want to represent any kind of a rational number which is negative, that you need to represent left side of a 0. Okay, here I have taken 4/5. Can you see any sign over here? No. So it is a positive rational number. So where it exists? So before that, you need to think whether it is a proper fraction or improper fraction. It is a proper fraction. Why? Numerator is less than the denominator. Numerator is less than the denominator. So it is a proper fraction. Always proper fraction exists between 0 and 1. Always proper fractions exist between 0 and 1. So I am just enlarging this, only this part I have enlarged. I am showing you now. Okay, now 0 and 1. Now what is the denominator here? 5. So make this 0 and 1 unit as 5 equal parts. How can we make 1, 2, 3, 4, 5? Clear? See, equally I have done. Okay, now what is the denominator here? 5. So on the top write down it is a 0 and 1 unit. It is a unit of 0 and 1, 0 to 1 unit, and I have done 5 parts. So the first number is, because I have done 5 parts, the first rational number will be 5, 0/5, 1/5, 2/5, 3/5, 4/5 and 5/5. If you want to check, you can check. Okay, like whether you have drawn correctly or not, you can check. 5/5 is what? 5/5. 5 ones are 5 ones are. 1/1 is nothing but 1 only. So 0/5, 0 by any number is 0 only. So whether you are writing the correct number in correct position or not, like this you can check. So where is 4/5 now? Here is 4/5. This is one example. See, you need to concentrate what I am explaining. You need to concentrate on each and every word which I am speaking. Okay, sometimes I'll make a mistake, but I'll make it correct again in next second only. So concentrate. 0 and 1, it is 1 unit. So I have enlarged 0 and 1 in this way because I want to represent 4 by 5. I want to show you. Okay, this you can do in imagination. The same 4 by 5 I cannot show you here, right? 5 times, so I cannot show you. It will be a very minimal, it is actually cannot see. So to make you explain, imagine I have enlarged. So I have divided into 5 parts. Why? Because the denominator is 5. So I have divided. So each and every number will be now, rational number will be now 0 by 5, 1 by 5, 2 by 5, 3 by 5, 4 by 5, 5 by 5. Now take another, any proper now. 3 by 7. Okay, 3 by 7. How to draw now 3 by 7? So 3 by 7 exists between 0 and 1. Why? Because it is a proper fraction. Always proper fractions exist between 0 and 1 only. If it is a positive proper fraction, if it is a positive one, it exists between 0 and 1. If it is negative one, it exists between 0 and minus 1. Here it is 0 and minus 1. Now let's draw a number line. Okay, what is the denominator here? 7. So you need to make a unit as 7 parts because the number is 7 here. I'm just drawing a number line just roughly. How many dots we need to put? We need to divide into 7 parts. To divide into 7 parts, I'm just drawing 8 dots here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I have drawn 8. I marked 8 dots on the number line. So the first one, last one, enlarge it. Okay, 3 by 7. I mean, draw a little bit longer. And 3 by 7. If you divide 3 by 7 is not. If you divide 3 with a 7, 1 the 7, it will not go. So 0.0. So it will become 30. Now what is the next number? 7 4s are 28. Like that. So 0.4. So 0.4 is nothing but 0 only. After 0 only some point, right? So always proper fraction exists between 0 and 1. So I am drawing here 0 and 1. Okay. Are you able to see? Okay, 0 and 1. Now how many parts we need to divide? 7. Whether it is there or not, let's check. Okay, 1, 2, 3, 4, 5, 6, 7. Exactly 7. And if you observe, there is equal distance between each and every line dot here. That is 1 centimeter. How I have drawn? Using ruler. Whatever denominator is there, to that extra 1.7 is there. So you need to put 8 dots. To first one and last one, just enlarge it and write 0 and 1. Write the mark 0 and 1 at the top. And at the bottom, because the number is 7 here, denominator is 7 here, 0 by 7, 1 by 7, 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7, 7 by 7. 7 by 7 is nothing but 1 or not. So it is matching. So where is 3 by 7 now? Here is 3 by 7. Clear? Are you able to follow me or not? Yeah. Let's discuss few more examples. Negative number now. Okay. Proper fraction over positive numbers we have drawn. Let's start negative numbers, negative rational numbers. Let's take any example. I'm discussing only here proper fractions. Proper. Okay, minus 3 by 4. Okay, minus 3 by 4. One more example. This is first one. Second one, I'll take any number. Minus 7 by what? 9. Okay, let's discuss. Okay, we need to 3 by 4. First of all, it is a negative number. These two are negative numbers. Okay, you need to think first whether it is a proper fraction or improper. Okay, 3 by 4. Normally, you just cover it. Okay, 3 by 4. 3 is less than 4. Okay, it is a proper fraction. When you are writing minus 3, so it is a proper fraction which is located in negative area. Okay, it is a negative rational number. Okay, clear? Are you getting my point or not? First, you need to think whether it is a proper or improper. 3 by 4 is a proper fraction. So it exists between 0 and 1. Because minus is there, it exists between 0 and minus 1. Okay, let's discuss first one. I'm drawing a number line over here. a small number line. Okay, next, what is the denominator here? Depending on the denominator only, you need to divide a unit into those many parts. Because the denominator is 4, you need to divide each unit into 4 parts. Okay, listen to me very carefully. Now 4, so because it is a proper fraction, it exists between 0 and 1. Because it is -1, it exists between 0 and -1. So because 4 is there, I am drawing 5 points. Okay, 5. I'm just drawing 5 points. 1, 2, 3, 4, 5. Okay, 5. So to first one and last one, enlarge. 0. When you are representing negative numbers or else negative rational numbers, you need to move to the left side, because all the negative numbers exist in left side of 0. Okay, 0 and here -1. Now what is and it is a portion -3/4. Okay, now what is the denominator? 4. So 0/4 -1/4 -2/4 -3/4 -4/4. What is 4/4? 1, because negative is there, -1. It is matching or not? 0/4 is 0, -4/4 is -1. Okay, done. Now where is -3/4? Here, round up. So this is how we are going to represent a rational number on a number line. Now one more example. -7/9. Second question, -7/9. Now what is the denominator here? 9. So how many points we need to take on a number line? Because 9 is there, we need to take 10. Okay, draw a number line first. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10. Okay, let me extend this. It looks somewhat neat. If I extend, actually you need to draw with a pencil. If I draw with a pencil, people are unable to see properly, so that is why I am using pen over here. So draw a little bit longer line to the first and last lines. 7/9 is a proper fraction first of all. So it exists in a 0 and 1. Because it is a negative number, it exists between 0 -1. When you are writing -1, you need to turn to the left side, you need to move to the left side. When you are discussing about the proper fraction positive one, you need to move to the right side, 0 and 1. Okay, now what is the denominator here? 9. So you need to make 9 parts. When you are drawing 10 points, obviously the spaces will be 9 only. Count 1, 2, 3, see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Clear? Now you need to start from 0. Okay, 0. So what is the 9? 9. 0/9. Left side when you are moving, it will become -1/9, -2/9, -3/9, -4/9, -5/9, -6/9, -7/9, -8/9, -9/9. -9/9 is nothing but -1. So in another case, 0, 1, -1, -2, -2. So this small part we are enlarging and showing you. Okay, I'm just enlarge this. I made into what I made it into 9 exact parts to represent -7/9. Whatever denominator is there, those many parts you need to do to 1 unit. 0 to 1 is 1. 0 to 1 is 1 unit. 0 to -1 is another unit. All the units are same length. It is going to have same length. 0 to -1 is 1 unit. Okay, because it is a negative number, negative rational number, it exists between 0 and -1. Because the denominator is 9, I made it into 9 parts. I have divided this 1 unit into 9 parts, and according to the denominator, below 0, 0/9, -1/9, -2/9, like that I have drawn. Okay, now where is -7/9? Here is -7/9 exist. Clear? Let's discuss one more. What is that? Take any number pa. minus 3/7. 7 already we have. Sorry, okay, -3/7. 3 by 7 is what? Proper fraction. 3 by 7 normally. Minus 3 by 7 exists in 0 and minus 1. Okay. Always proper fractions exist between 0 to the numbers which exist between minus 1 to plus 1. All these are called proper fractions. Okay. Negative. I'm sorry. Here negative proper fractions will exist, and here positive proper fractions exist. Clear? Now I'm enlarging now. 0 to minus 1 we need to take. Draw a number line because the denominator is 7. So you need to take 8 points on that. 1, 2, 3, 4, 5, 6, 7, 8. Enlarge first and last because it exists in negative numbers, so you need to draw 0 and minus 1. Okay, now 7 parts. 1, 2, 3, 4, 5, 6, 7. Yes, 7 are there. 0 by 7, minus 1 by 7, minus 2 by 7, minus 3 by 7, minus 4 by 7. Minus 7 by 7 is nothing but minus 1. It's matching. So where is 3 by 7? Minus 3 by 7 here. Clear?